In this short video, we will consider some practical aspects of seismic recording. We will differentiate between the picket numbers in the field and channel numbers in the recorder. We will also differentiate between geophone interval and geophone group interval. As we know, the two most common type of seismic sources are dynamite and vibrosize. Therefore, we will use short point or SP for dynamite sources and vibrosize point or VP for vibrosize sources. Our seismic source also generates surface waves in the form of ground roll noise. Thus, to suppress the ground roll noise, an array of geophones, also called geophone group, are used at each receiver point, which are connected to a single recording channel. Thus, geophone group interval refers to receiver interval, while geophone interval refers to separation between two geophones in a group, which is equal to half the wavelength of ground roll noise. Now let's consider a seismic line with marked picket numbers. Now the picket interval is also the receiver interval. This is an individual geophone, while together they make up the geophone group. All the geophones in the group are connected in parallel to a single recording channel. In this way, each picket has a geophone group which is connected to a channel in the recorder. As we can see, the geophone group interval is the same as the picket interval or receiver interval, while the interval between two consecutive geophones is the geophone interval. Now let's consider the ground roll, which is a coherent noise and therefore has a wavelength. Now the geophone interval is set to half the wavelength of ground roll. In this way, half number of geophones in the group will pick the peak of ground roll, while half of them will pick the trough of the ground roll. And therefore ground roll will have a destructive interference and will cancel out. Now let's consider the link between the picket numbers in the field and channel numbers in the recorder. We consider a recorder with only 8 channels. As we can see, the geophone groups at pickets 101 to 104 are respectively connected to channels 1 to 4 of the recorder. Similarly, the geophone groups at pickets 106 to 109 are respectively connected to channels 5 to 8 of the recorder. The source is placed at picket 105. This whole layout geometry can be written in the form of shell processing support SPS formatted file. As we can see, this is the short point. On the left side, the geophone group at picket 101 is connected to channel 1, while geophone group at picket 104 is connected to channel 4 of the recorder. Similarly, on the right side, the geophone group at picket 106 is connected to channel number 5, while geophone group at picket 109 is connected to channel number 8. The geophone groups at the in-between pickets are also connected to their respective channels. Now for the next shot, we can see the switching between the channels and the geophone groups changes. And therefore the next two records in the SPS script will indicate that the shooting has been carried out on picket number 106. It must be noted that the number of geophone groups being laid out in the field is much higher than the number of channels available in the recorder. During acquisition, the recorder switches the channels with different geophone groups according to the spread geometry.